Lesson 12-1, Solving Addition Equations. And in this lesson, you learn to solve addition equations by using models. When are you ever going to use this? Knowing how to solve equations can help you determine golf scores. So let's take a look at this example in Monopoly. Justin is playing a board game and needs to roll an 8 so it can land on community chest. If he rolls a 5 on the first number cube, what must he roll on the second number cube? And we will solve this in example 1. Okay, so you can use cups and counters to solve equations. Okay, a cup represents the unknown value, so that will be our variable. You'll find out later on. Yellow counters represent positive integers, and red counters represent negative integers. So let's see how we can use cup and counters to solve this equation, and I'm going to tell you the property that's associated with this lesson. So let's go back. Refer to the beginning of the lesson. What must Justin roll on the second number cube? So what do we know? We know that the number in the first number cube is 5. Justin wants a total of 2 number cubes to be equal to 8. And just like any word problem in algebra, we need to define our variable. And in defining our variable, we use what we call a let statement, meaning you start with the word let. So in this case, let D represent the number tossed on the second number cube, and we will translate the problem into an equation using the variable D. And we will also model the equation and then solve. So if you notice, this type of question is so easy to solve, you know right away that the answer is 3. But in this lesson, we are trying to solve equations the algebraic way, meaning as we go into more complex equations, this is the way you should be solving those equations. Okay, so let's solve this simple equation using algebra. Okay, so we know that the number on the first number cube is 5, and we add it to the number on the second number cube, which we represented as D, and this should equal the sum of the two numbers, which is 8. Okay, and if we model this the number in the first number cube is 5. We have 5 counters, and D represents our cup. Okay, so again, this can also be our variable. Okay, and 8 represents 8 counters as well. Okay, so our D will be represented by the cup. And before we solve this type of equation, you need to understand that in an equation, it is like a balance scale. So it does not tip over. This is our entire equation. It's balanced. Okay, what's on the left side balances on what's on the right side. Very similar to this one right here. Okay, so this is your x plus 5 equals 8. Okay, and if you notice, both sides are balanced. Okay, now if you take a look at this one, if I take out one of the number cubes, look what will happen to our balance scale. It's not anymore balanced. So to be able to create x plus 5 equals 8, I need to have 8 cubes here, 3 cubes here, and this is our cup x. So we bring back that 1, and now we have x plus 5 equals 8. Okay, and to be able to solve this type of problem, and going back to what we have back here, you have x plus 5 plus D is equal to 8. To be able to solve this, okay, we need to isolate our cup on one side of the equation. So we need to isolate our variable. Our cup is actually our D, okay, on one side of the equation. And remember, since it's a balance scale, okay, whatever you do to one side, you need to do exactly to the other side, or else it's going to tip over. Okay? So again, going back here, whatever I do to this side of my equation, I need to do to the other side so that it will remain balanced, or it will remain equal. Okay? So we have 5 positive counters and our variable, and we have 8 positive counters here. Again, our objective is to isolate our cup, meaning leave it on one side of the equation. The only way to do that if we take away 5 counters on this side. So that means we also need to take away 5 counters on that side, and that's exactly what we did. Take out 5 counters on this side. Okay. Take out 5 counters on this side. Okay, that's and we also take out 5 counters on the right side. So whatever we did on the left side, we do on the right side. And if you notice when you come back to school, that will be commandment number 8 on our commandments of math. Whatever you do to one side of the equation, you need to do to the other side. Exactly. So in this case, we took out 5 counters. We need to take out 5 counters on the other side as well. So if you notice, when you do that, you're left with your cup by itself, and you're only left with 3 positive counters. Okay? So the solution is 3. Justin must roll a 3 on the second number cube. Okay? And if we go back to our balance scale, which is this one, again, to be able to solve for x or isolate x on this side of the equation, we need to subtract 3, okay, to both sides. So we subtract 3 like what we did. I'm sorry, we need not subtract 3, subtract 5 to both sides of our equation. And then if we subtract 5, well, let's see. Okay, if we don't subtract 5 and we only subtract 3, look what's going to happen to our equation. It's still going to be the same, but look what happens. Okay, the x is not isolated. So our objective is to isolate x and make sure it's all by itself on the left side. Okay, so we subtract 2 more, and that makes our answer x is equal to 3. Okay, so basically what we did, we simply subtracted 5 to both sides of our equation, which made our equation remain balanced. Okay, so whatever you do to one side of the equation, you need to do to the other side. So we subtracted 5 here, we need to subtract 5 on that side. So let's see if our answer makes sense. Check the solution by replacing the value of the variable in the original equation. So the value of our variable is 3, so we simply substitute it back to the original equation, which is 5 plus d is equal to 8. So we substitute 3 with d, and then 5 plus 3, is it equal to 8? Yes, it is. And we've checked our solution to be correct. Okay? And this brings us to the rule that we are going to follow. And this is what this particular rule that we did, okay, is what we call the subtraction property of equality, which simply states that let a, b, and c, any 3 real numbers, if a is equal to b, if you subtract a with c, you need to subtract b with c as well. Again, going back to whatever you do to one side of the equation, you need to do to the other side as well. Okay, and let's follow this rule. Okay, in example number 2. Example number 2, again, we use cups and counters to solve c plus 3 equals negative 9. Okay, so use a cup to represent c. Add 3 positive counters on the left side of the mat to represent plus 3. And then, this is what you have right here. So c represents the cup, and 3 positive counters represents plus 3. Place 9 negative counters on the right side of the mat to represent negative 9. And that's what we have. Okay? Again, we want to isolate our cup, or isolate our c on one side of the equation. And to be able to do this, okay, to get the cup by itself, you need to remove 3 positive counters from each side. Okay, but the thing is, remember our rule, whatever you do to one side of the equation, if you subtract 3 positive counters here, you need to subtract 3 positive counters on the other side. Problem is, since there are no positive counters on the right side of the mat, we need to add 3 negative counters to each side to make 3 0 pairs on the left side of the mat. Then remove the 0 pairs. Okay, basically this is what it's saying. Basically we add 3 negative counters. Okay, and now we remove the 3 negative counters. Okay, by adding Uh, we add 3 negative counters to each side to make 3 zero pairs on the left side of the mat. Okay, and then we simply remove the zero pairs. So what we did, we put 3 negative counters, we made 3 zero pairs, we removed the 3 zero pairs. Okay, so we now have uh, C plus 3, okay, plus negative 3, okay, and that's what we added, negative 3, okay, and since we added negative 3 to the left side of our mat, we need to add negative 3 to the right side of our mat as well, okay, and that's what we did. And if you notice, the negative counters increased by 3, so the cup now by itself, okay, so the cup by itself will be C, and this now becomes negative 12. So C plus 3 equals negative 9 is equal to negative 12. So basically this is C is equal to negative 12. Okay? Now from there, we want to check if our answer is correct or not. So we add C plus 3 is equal to negative 9. We replace C with 12. So we now have negative 12 plus 3, is it equal to negative 9? And we know that it is. Okay? And that's how we checked our answer. The solution is negative 12. Okay? So that's how you use counters to isolate the cup or the variable in addition equations. Okay? Let me give you another example. Let's say you have 6 plus x is equal to negative 5. So 6 plus x is equal to negative 5. Okay. Again, if we use counters for this, you'll have 6 positive counters. Okay. And you will have the cup. So let's do that. Let's make a rectangle first. Okay. So this is our addition mat. Equal sign. So you have 6 plus negative x, 6 positive counters. Okay. And let me make my positive counters blue, negative counters red. 1, 2, 3, 4, 5, 6. And you have an x right there. Okay. We'll make it a cup, just like what we've been doing. So we'll make it a cup. Okay, that's our x. And then negative 5, I'll make that red. 1, 2, 3, 4, 5. Okay? So just like what we did in this example, to get the cup by itself, we need to remove, instead of 3 positive counters, we need to remove 5 positive counters from each side. But the problem is, since there are no positive counters on the right side of the mat, we simply add 5 negative counters to each side to make 3 zero pairs, and then we simply remove the zero pairs. So in this case, instead of, sorry, I'm always saying 5, instead of taking away 6 positive counters on the right side, there are no 6 positive counters to take out, we simply add 6 to negative counters on this side. Okay, and again, whatever we do to one side of the equation, we need to do to the other side. So what we did here is that we have now 6 plus negative 6 plus x is equal to negative 6. Remember, we added negative 6 here, so we add negative 6 counters again. 2, 3, 4, 5, 6. Okay, plus negative 6 right here. Okay? And from there, we isolated our variable, because what happens now is that these are all zero pairs. We take them out. We've isolated our variable to become x. Okay? And we simply count the number of negative counters, which is negative 12. So 6 plus x equals negative 5. Okay, the solution would be not negative 12, I'm sorry. Miscounted, that should be negative 11. Okay? Because this is negative 5. There you go. Okay? So we now have x is equal to negative 11, and if we want to check if our solution makes sense or not, we simply get negative 11 and substitute it back to the original equation. So we now have 6 plus negative 11. Is it equal to negative 11? Sorry, negative, what am I doing? Now, is it equal to negative 5, which is the original problem? Okay, and we find out that it is. Negative 5 is equal to negative 5. We've checked our answer or our solution to be correct. Okay, and the secret word for this particular lesson will be wildcats. The secret word is wildcats. Thank you for watching.